So the most important thing with related rates is to, well, practice. The more problems you see and do, the better you're going to get at this. So this is a completely ridiculous example. I have no idea why we have a rectangle that just seems to be changing lengths. I don't know. Maybe we're zooming in and zooming out on something. Wow, I'm blocking stuff. So I wrote down the basic rules for solving related rates over there as quick and easily as possible. And we have a situation here. Apparently we have a rectangle. It was 10 by 6, almost the size of a sheet of paper. But for some reason, this is growing or shrinking or something like that. Let's find out. For part A, what you need to do is come up with some basic equations. So when we're talking about the perimeter, and it is a rectangle, hopefully that jars your memory and you say, gosh, I think I know how to find the perimeter of a rectangle. 2 times the length plus 2 times the width. I also asked about area over here, so perhaps you know the area formula for a rectangle. Length times width, that might work. Base times height, however you feel like putting it. There is one more thing. It says how fast is each changing in terms of L and W. So what we're asking for here is a rate of change. And these must be related rates. Maybe the change in the length and the width are related to each other. We'll find out. Let's go to step 2. Plug in the constants. Here's what I mean by constants. We have a perimeter. Throughout the course of this amazing growing rectangle, is the perimeter going to stay the same? Is it a constant number? No. I think it's probably growing or shrinking, depending upon what's happening. Is the length of the width staying the same? If I actually were to read down here, I'd see that no, they're not staying the same. I don't really have anything that's constant. So step 2 is pretty well done. There's nothing there. There's no constant numbers to plug in. I'll talk about auxiliary equations later, therefore more complicated problems. So let's just get to the deriving here, shall we? Well, that wasn't too hard. We had a bit of a product rule situation going on over here, but yeah, no big deal. Basically, all I have left is to plug in values and solve. So here's where it comes to identifying what these things are. We're told that the dimensions are 10 and 6. So I'm just going to go ahead and say the length must be 10 and the width must be 6. That's a very vague question. I probably should fix that. But then read part B. Well, excuse me, part A. This does tell me how the width and the length changes are related to each other. But let's go to part B here. It seems to me that they're telling us some information here. The length is changing by 2, and the width is changing by 2 inches per second. Okay? I bet with that kind of information, we can find how the perimeter is changing. Let's just plug in the numbers. I have a perimeter formula here. 2 times dl dt plus 2 times dw dt. And if we really want to do this right, I'm going to give you the units. We're talking inches per second. That, my friends, is the answer to part B. Now, for part C, let's look for a moment. For part C, we're talking about the area changing. So I came over here to the side with the area formula and the related rate of area. They told me that things were changing. Now the length is getting smaller and the width is getting bigger. So we're going to take that information, use the exact same equation. There's nothing to do except for plug in the numbers where the variables happen to match. dl dt is -2. The actual width, if you remember, was 6. dw dt is 1/2, and the original, length is 10. So I believe -12 plus 5. This is shrinking, but is it in inches per second? Think about the units here.